Hello everyone. Today we are discussing about the course Fundamental of Power Electronics, whose course code is 22326, semester 3rd of the program Electrical Engineering. Now let us discuss firstly about the course outcomes. There are 5 course outcomes. After completing this course, you have to get the knowledge related to these outcomes. First A is related to the topic number first. Topic number first is Introduction to Power Electronic Devices. So the first outcome is select power electronic devices for specific applications. Power electronic devices such as power diodes, thyristors, power transistors, power MOSFET, IGBT, SIDs, or the whole thyristor family which contains SCR, GTO, then LASCR, TRIAC, DIAC, etc. Okay. Now next is the maintain the performance of thyristor, which is related to the topic number second, thyristor family devices. Third is the troubleshoot turn on and turn off circuits of thyristor, which is related to the unit number 3, turn on and turn off methods of thyristor. Now next outcome is maintain phase controlled rectifiers, which is related to the unit number 4, phase controlled rectifiers. And last is the maintain industrial control circuits, which is related to the unit number 5, industrial control circuits. These are nothing but the outcomes. You have to gain the knowledge about the particular unit or particular chapters, then you are eligible or able to get the knowledge related to whole course or whole subject. Now next is the teaching and examination scheme. Your whole syllabus contains 150 marks, which is divided into two parts. One is theory and the second is the practical. Theory is 100 marks, in which end semester exam, that is ESE, is 70 marks, and PA, progressive assessment, is for the 30 marks. Also in the practical there is end semester exam 25 hash, includes external exam is there, and PA means progressive assessment is 25 marks. That means theory is 100 marks and practical is 50 marks, so the whole subject is 150 marks. Okay. Now the next is the suggested practical list. There are total 18 lists as per the MSBT. There are mandatory 12, minimum 12 experiments or practicals are need to be conducted, out of which star marks are compulsory, or these are related to particular unit. Okay, so this is nothing but the whole list about the practicals. Now moving forward towards the major equipment, as we already know, our institute is NB accredited. Because of that, there are bulk quantity of instruments, so we are able to perform whole experiment, and each and every student is able to perform these given practicals, or practical will be conducted individually. There are some major equipments like digital multimeter, DSOs, CROs, then the SCR, LASCR, SCS, GTO, UJT, DC regulated power supplies, experiment kits, resistive loads, and tachometers are also available in the labs. Okay. Now moving towards the theory content, first unit is power electronic devices. In the power electronic devices, we will see why it is called as a power electronic devices. Okay, there are many electronic devices, but why the particular devices are called as power electronic devices? Some of the power transistor, then the IGBTs, then single electron transistor. Also we will see the aspect of nanotechnology here. Now moving forward towards the unit number 2, that is thyristor family devices. Consider here or make a note of the point that if you are able to see the thyristor or if you are able to achieve or gain the knowledge related to the thyristor, then you are able to pass or to qualify maximum marks or get the maximum marks in the particular subject. Okay, thyristor family devices is nothing but the SCR. Thyristor family devices contains SCR, GTU, LASCR, triac, diac, some of the nothing but there are some triggering devices, there are some power control thyristor. Also we will see here some protection circuits, because there are some, in some cases over voltage, over current will happen. To control it, there will be some protection circuits are available, which will be we have to see in the particular chapter or particular unit. Moving forward to the unit 3, turn on and turn off methods of thyristor. Thyristor is basically three terminal devices, which is cathode, anode or gate. As we seen diode, diode is nothing but two terminal devices, anode and cathode, but in SCR or in thyristor, gate is used because gate, with the help of gate, SCR is used to be turn on. Also if SCR is going to be turned on, then it is difficult to make it off. So for that, turn off methods are also used. Now there are various turn off methods like class A, class B, class C, class D and class E. Also there is class F. Okay, now next is the unit number 5, phase controlled rectifiers, in which we will discuss about the definitions related to the firing angle. Conducting angle means firing angle is the angle at which SCR is start to be conducted. Okay, and conduction angle is nothing but the particular period for which period SCR is on, means at which angle SCR is turned on, it's called as firing angle, or for which period SCR is turned on, then it is called as a conduction angle. Now there are some types like single phase half controlled, full controlled, midpoint controlled rectifiers with the R and RL loads. Here one basic concept we need to be discuss, why it is called as a controlled rectifiers. Now here we need to be discuss why it is called as a controlled rectifiers because its output is controlled. In the diode, output is fixed, means if we are getting output 5 volt, then it will not be altered. In the phase control rectifier, by changing its firing angle or conduction angle, we have to change the output, that is 5 volt, it may be 4.5 volt, maybe 4 volt, maybe 3 volt. Okay, so the phase control rectifiers are those rectifiers whose output is controlled by using the thyristor family. Okay, now moving towards the next chapter is unit number 5, industrial control circuits. Industrial control circuits means those circuits which are used power electronic devices or applications are based on the power electronics engineering, such as burglar alarms, battery charger, emergency light system, temperature controller, speed controller, switched mode power supply, which is nothing but the SMPS. Most useful instrument is UPS, uninterrupted power supply. If the light is off, then UPS is used, that is offline and online are the two types of the UPS. And last in nothing but SCR based AC and DC circuit breakers. Okay, now next point is the distribution of marks for the particular unit. Unit number first, power electronic devices, which contain 6 marks. Thyristor family devices, which contain 17 marks. Third unit, turn on and turn off methods of thyristor contains 14 marks. Fourth, phase control rectifiers, which contains 18 marks. And last, fifth, industrial control circuit, which contains 15 marks. So the total of the marks is 70. So the theory subject is 70 marks. Now next is the suggested micro projects. One micro project is planned to be given for the batch, with the batch conduct having 3 students not exceeding 3. Okay, the subjects are like this: power electronic devices, build and test the circuit of electronic switch using power thyristor. Second is thyristor family device, build and test the circuit of digital logic gates and or not, NAND, NOR, etc. Third is turn on and turn off methods. Then next is phase control rectifier. Next is industrial control circuit. If you are sincerely appearing for the practicals, then these micro projects are very easy, so don't take tension. You have to able to make or build the circuit within a stipulated given period. Now the next is the suggested learning resources. That is, my notes are sufficient, but if you want to get extra knowledge, then you have to use Power Electronic and Application Jain and Alok book, or also the McGraw Hill publication Industrial Electronics books. Okay, now we will discuss about the first chapter in this. The first chapter is Introduction to Power Electronic Devices. First, let us discuss about the power electronics. What is meant by power electronics? Power is nothing but the multiplication of voltage and current. P is equal to V into I. But if maximum voltage and maximum current is given, then it will produce maximum power. So why we need a maximum power? Because there are some instrument or some devices which will run with the help of maximum power. Such applications as heat control, induction heating, power supplies, conveyors, cranes, electric vehicles, then motor control, HVDC system, light dimmers, washing machines, dryers, furnace, grinders, pump, compressors, air conditioners, refrigerators, machine tools. These are all operated with the help of high power. So in this case we need high power semiconductor devices. These are requirement for the power devices, that is large current and large voltage, to run these applications. Okay, there are some power semiconductor devices, such as power semiconductor devices is classified into the power diodes, thyristor, power transistor, power MOSFET, IGBT and SIT. Okay, but we will discuss briefly about the thyristor family, which includes SCR, GTU, LASCR, etc. Now looking to the next point, need of high power semiconductor devices. Why we need high power semiconductor devices? The applications which are mentioned earlier, we need to use large power, that is large current and large voltage, because these are nothing but the high power applications. So it uses high power devices. Therefore there is a need of high power electronic devices. Okay, so what is the requirement of power devices? These devices should be capable of handling large current and large power. In the off state, they should be able to withstand very high voltage. In the on state, resistance should be small. It should be turned on and off completely and quickly, and its cost should be low. Okay. Next is the thyristor family. Again, thyristor is divided into the two types. One is a power control thyristor, second is the triggering device. Thyristor control devices are also two types, unidirectional or bidirectional. The thyristor is nothing but the SCR. Okay, SCR is nothing but the silicon controlled rectifier. Okay, there are two types of devices. One is unidirectional and other is the bidirectional. Unidirectional are those in which current is flows in only a single direction. Bidirectional are those in which current are flows into in the both direction. Okay. Triac is made with the help of two SCRs. SCR is unidirectional and triac is used with the help of two SCRs. Because of that, triac is bidirectional. And unidirectionals are SCRs, LASCR, SCS, LASCS, SUS. These are nothing but the examples. In the next upcoming chapters, we will discuss about the whole. Now next are the triggering devices, means power controlled thyristors are nothing but the actual device which generate maximum powers, and triggering devices are only the triggering. Triggering is nothing but the turn on, to whom these devices are used to turn on to the SCRs, to the LASCRs, to the SCS, to the LASCS, to the SUS, to the tri. Okay, means UGT, diac, SBS, SUS are not the power generating devices. These are only the triggering devices. Okay, so the classification of thyristor are power control devices and triggering devices, in which power control devices actually generate maximum power and triggering devices are actually used to make turn on to the thyristor devices or unidirectional or bidirectional devices. Okay, moving toward the next applications of thyristor. Applications of power electronics are nothing but the applications of thyristor, or applications of thyristor are nothing but applications of SCR. These are temperature controller, level controller, intensity controller, speed control of AC and DC motors, fan regulator, battery charger, DC to DC choppers, power inverters, static switches, cycloconverters, HVDC transmission, etc. Now we will discuss about the SCR symbol and basic structure of SCR. Silicon controlled rectifier, that is SCR, looking like this, is a three terminal device, that is anode, cathode and gate. SCR is nothing but the one of the oldest type of solid state power devices. It was invented in 1957. SCR have the highest power handling capacity of all the power semiconductor devices. As we have seen in the symbol, anode, cathode and gate. Gate is used to triggering devices, means it is used to make it on to the SCR. If the current flows from the anode to cathode, then it is called as a forward bias condition. If the current flows from the cathode to anode, then it is called as a reverse bias condition. Now looking towards the basic structure of SCR. In the basic structure of SCR, they have 4 layer construction. There are 3 junctions, there are 3 terminals. SCR is a device that can be turned on by using the control terminal gate, but as it turns on, gate loses its control over the SCR. There are some important features about the SCR. It is latching time device. It can handle very large power. It is current control devices. Voltage drop is very low. Okay. Now next, in the construction, there are 4 layers, that is P1, N1, P2 and N2. There are 3 junctions, that is junction 1 in between P1 and N1, junction 2 is in between N1 and P2, and junction 3 is between P2 and N2. Why it is called as a semiconductor? Because P type and n type are nothing but the semiconductor, means it have characteristic between the conductor as well as in the combination of the conductor as well as the insulator. There are positive type of semiconductor or negative type of semiconductor are used. In the positive there are majority is holes, and in the negative type semiconductor majority is electrons. So don't get confused about all these. In the next lecture we will see about the characteristic of the SCR. Firstly we will discuss about the chapter number 2, which will be easy to discuss or to understand. Therefore we will skip the first chapter and go towards the second, then move towards the first. In the first, the majority part, that is power electronic devices or its application, is already we have discussed in this lecture. In the next lecture we will discuss about the SCR families, and then we will move towards the power transistor, IGBT, and concept of single electron transistor. For the today's, that is all about thyristor family. Thank you.